Hello everyone, we from group number 6 want to present. First of all, I Stephen Ekaputra would like to introduce the member of our group. There are Angelo, Cindy, Gemma, Dava, and me. And thank you for being here today. In this presentation, we will explore a crucial aspect of operating system, CPU scheduling. The CPU is a vital research and managing how process utilized. It is key to ensuring efficient performance. CPU scheduling is the process of determining the order in which tasks or process will be executed by the CPU. It is essential because the CPU is a limited resource and often multiple processes need it simultaneously. Effective CPU scheduling ensures that the CPU is utilized efficiently, minimizing the time process spent waiting for their run. This leads to improved overall system performance. There are several common CPU scheduling algorithms, including first come first serve or Fcfs, short job first or SJF, round robin, and priority scheduling. Each has its strengths and weaknesses. The Fcfs algorithm is one of the simple scheduling methods. In this approach, processes are executed in the order they arrive. The first process in the queue is the first to be executed, without regard for priority or execution time. In conclusion, effective CPU scheduling is essential for optimizing system performance. Understanding different algorithms helps us choose the right one for specific scenarios, ensuring that CPU resources are used efficiently.
And the example that we have here, process 1 to process 5, and then the AT means arrival time and BT is burst time, or the time required for the process to be executed. Now remember, by the name itself, Fcfs stands for first come first serve, meaning the one that arrive first are the one that's going to be served and executed, meaning that in sequence P1 is going to be the first, P2 is going to be second, P3 is going to be the third, P4 is going to be the fourth, and the P5 or the process 5 to be the fifth. To get the CT or finish time, we're gonna need to accumulate the arrival time and burst time for the first time. For example, is the process 1 have the arrival time of 0 and the burst time of 3. 0 plus 3 is 3, but after that the CT is from the CT before that process plus the burst time of the process itself. For example, for the process 2, the CT is 3 plus 5 equal 8, and for the process 3 is 8 plus 7 is going to be 15, and the process 4 is the finish time of P of process 3 plus the burst time of process 4, that's going to be 15 plus 2 equals 17, and then the process 5 is 1 plus 17 is going to be 18. After we got the CT or finish time, we are now going to find the TAT or turnaround time, and that is by subtracting CT with AT. For example, at the process 1, is going to be CT3 minus 80 of P1 is 0 equal 3. At the process 2, CT8 minus 82 is going to be 6. Process 3, 15 minus 3 is going to be 12. Process 4, 17 minus 5 equal 12. And then process 5, 18 minus 7 equals 11. Next, we're gonna need to find the WT value or waiting time, and that is by subtracting TAT with the BT. For example, at the P1, the TAT number is 3 minus BT is also 3 equal 0. P2 is 6 minus 5 equal 1. P3 is 12 minus 7 is going equal 5. And a P4, 12 minus 2 equal 10. And P5 is 11 minus 1 equal 10. And then we find the average number of TAT and WT is by accumulating all the value of let's say turnaround time, and the number is 64 divided by the number of the process. Here we have 5 processes, meaning it's going to be 64 divided by 5 equal 12.8. The same thing with waiting time. The sum of the waiting time is 26 divided by 5 equal 5.2. Now let's take a look at the Gantt chart and how it works. So first, at the time of 0, the process 1 is already arrived. Then the process 1 is going to be executed until it's done, because the burst time is 3, meaning it's gonna take 3 time. After it finished, we are moving to the process 2, and it's gonna take 5. Process 2 is executed until it's done at the time of 8. And next, we go to process 3 at 8 until it's done at 15. And after that, we move to process 4 until it's done at 17. And then we go to process 5 until it's done at 18.